So for our Unit 9, let's start with our graphing. The first thing to be able to do is to recognize what we're graphing. So the fact that this is a plus sign in the middle tells me that, and we've got a different denominator for each one, this tells me that we're talking about an ellipse here. Right, so we're going to say ellipse. The center of this ellipse is always the HK, H following with the X. So we would say it's opposite of what we think. So a -1, +4 in this case. We won't have a radius. We will have foci. We won't have asymptotes. We will have vertices and covertices, and the focus and directrix is for parabolas. So the first thing I might do to get the rest of these things is just simply to graph the center. So -1 up 4, plot that point. And then in the x direction, we're going to go out. If a squared is equal to 1, then a is equal to plus and minus 1 when we take the square root. So in the x direction, we're going to go out 1 and -1, right? 1 in each direction there. If y, underneath the y variable, we've got a b squared value of 36, then b is equal to plus and minus 6 from that center point. So I'm going to go up 6, which is here, and down 6, which would be here. And so we've got this really narrow ellipse that is elongated in the y direction because the bigger number is under y. The foci I am expecting to be, remember, always in that y direction then if we're elongated in y, so somewhere in that vicinity where the green dots are. So we're going to use that, well, actually we could probably fill in the vertices here. Vertices are going to be the elongated direction. So this is a vertex and this is a vertex. And then the co-vertices would be these guys. So let's actually just identify those. So our vertices would be -1 up 10 and -1 down 2. Our co-vertices would be at 0, 4 and -2, 4. And our foci will be found using the wonky Pythagorean theorem, right? The a squared minus b squared. So let's do this as c squared is equal to, I just try to keep it positive, so 36 minus 1. So c squared is equal to 35, or c is equal to plus and minus the square root of 35. So what does that mean? It means from the center, so our foci are going to occur from the center, -1, 4, and from that center point in the y direction only, we're going to go up the square root of 35, and then similarly, -1, 4, from that center, we're going to go down the square root of 35 in that y direction. Okay, number 2, in the middle. This one, again, clearly, we look for that, some defining characteristics. The minus sign in the middle makes this guy a hyperbola, cannot be anything else. So we have a hyperbola. The center of a hyperbola, be very careful, is the HK. So it kind of looks like we're going backwards. It would be 0, -3. So we can actually plot that, 0, -3. We don't have a radius. We do have foci. We will have asymptotes. We really don't talk about co-vertices, focus, and directrixes, again, for the parabola. So in the x direction, we're going to go out, right? If this is a squared here is 16, then a is equal to plus and minus 4. So we're going to go out 4 from that center point in both the x directions. And then similarly in y, we would go up and down 3. This creates the box for us. We know that out the corners of the box will be our asymptotes. And we can also see that this is going to be a y squared parabola because y is listed first, which means we open in that y direction. So we're going to open up and down and then use those asymptotes to guide the graph there. So these guys at the top and bottom of the box are the vertices, right? So if we wanted to identify that vertex at the top and bottom of the box there, so that would be at 0, 0 and 0, -6. As far as where the asymptotes are, we're just doing y equals mx plus b. So counting our rise and our run of the asymptote up 3 over 4. This would make this y equals 3/4 x, and then a y-intercept is -3. Similarly, to go to the bottom, to the negative asymptote, we're going to go down 3/4. So this would be y equals negative 3/4 x. And again, the y-intercept is still negative 3 there. So those are the two asymptotes. I'll just circle those. And then finally, for our foci, we will expect them to be in the bowl of the parabola. So somewhere in this vicinity where I'm drawing them. But this one, we're going to use the correct version of the Pythagorean theorem, if you will. Right, the one that looks correct. So our a squared and b squared are the 9 and 16, the denominators of our formula. So 16 plus 9, c squared is equal to 25, or c is equal to plus and minus 5. That means we're going to go up and down 5 from the center point, which I've now got kind of highlighted in red there in the middle. So up 5 from there would be here at 2, 0, 2. So that's one focus point, 0, 2. And down 5 from that red center would be at negative 7. Oh, sorry. Negative 8. So then the next one would be 0, negative 8. Asymptotes are in the red. Okay, the last one. Okay, so we are going to do a parabola here. This is an x squared parabola. So that means we're either opening up or down. Because of the negative, we're going to be opening down. So I'm expecting this to be a parabola, and it's going to open down. That means we're really not talking about a center. We're really not talking about a radius, foci, asymptotes, vertex, none of this. We're really talking about, well, I guess vertex. Yes, we do have one vertex. And then focus and directrix are what we're looking for here. So our center is really our vertex. That's our HK here. So this is your H and K, again, opposite of what we're expecting. So our vertex here would be negative 5, positive 2. So negative 5, positive 2. From there, we're going to be opening downward. So we look for this p-value, right? If we know that this is p must be negative 1 in order for this to be 4p. So p is negative 1, which means from our vertex point, we're going to go down 1 and up 1 would be that directrix. And so we're expecting a parabola that looks something like this. To figure out how narrow or wide this parabola is, we'll have to test a point. So we can quick fill in our directrix. Would be the line y equals 3. Our focus would be the point negative 5 up 1. To figure out how wide or narrow the parabola should be, let's test a point. In this case, we'd want to use that focus line. So we'll test a y value of 1 back up into our original formula. So x plus 5 squared equals negative 4 times 1 minus 2. So this becomes negative 4 times negative 1, which equals a positive 4. We solve this resulting equation, take the square root of both sides. X plus 5 is equal to plus and minus 2, or x is equal to negative 5 plus or minus 2. That means we end up with two ordered pairs here. Negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7 with the same y value. So now we can actually remove this and figure out how narrow or wide this parabola should be. So negative 3 up 1 and negative 7 up 1. Now we know definitively. Sorry, I had one more to do, and I didn't even know my marker. Okay, come on in. First,